What do undefined values tell us about rational functions? Imagine trying to divide a number by 0. Sounds impossible, right? In math, when we work with rational functions, something similar happens. Undefined values pop up when the denominator of a rational expression equals 0. These are the points where the function just cannot be evaluated because division by 0 is not allowed. To find these points, we set the denominator equal to 0 and solve for the variable. The solutions we get are called restricted values or excluded values because the function simply cannot take those inputs. Understanding these undefined values is really important because they tell us where the function is not allowed to go. They help us figure out the domain of the function, which is all the input values where the function makes sense. If a value makes the denominator 0, that value is not part of the domain. This is like a boundary that the function cannot cross. These undefined points also reveal features of the graph. If the denominator becomes 0 but does not cancel out with anything in the numerator, the graph will have a vertical line called an asymptote at that point. This shows that the function shoots up or down infinitely near that value. On the other hand, if the 0 in the denominator cancels with a 0 in the numerator, the graph has a hole at that point. This is called a removable discontinuity. Because the function is undefined, their but could be made continuous if we simplified the expression. Knowing where the function is undefined also helps when solving inequalities involving rational expressions. It prevents us from considering invalid solutions and helps us understand the behavior of the function better. For example, take the rational function of x plus 4 over x minus 3. To find where it is undefined, we set x minus 3 equal to 0, which gives us equals 3. At this point, the function cannot be evaluated because it would requiring dividing by 0. So, the domain includes all real numbers except 3. The graph will have a vertical asymptote at x equals 3, showing us exactly where the function cannot be evaluated. In summary, undefined values tell us where a rational function cannot be evaluated. They mark the boundaries of the domain and highlight important features like asymptotes and holes in the graph. Recognizing these points helps us understand the limits and behavior of the function, making it easier to work with rational expressions and inequalities confidently.